processing at any given point of time. Okay, so when it comes to scalability, so relational databases, you can think of interactive OLAP solution like a small sports car. And when it comes to Hadoop, Hadoop is not like a sports car. It is more of a it's more of an engine which which pulls heavy goods carriages and pulls heavy duty kind of a stuff, right? So scalability is the key aspect. It provides unlimited scale and keeps the data forever, and it does auto scale. You don't need to manage the scalability aspects of it, and it handles the commodity. It handles the scale with the commodity infrastructure. Virtually, I'll keep saying unlimited scale. But practically there would be some limit, but you can try out to whatever you would require to scale. Moreover, Hadoop offers you horizontal scale versus where RDBMS focus is on the vertical scale. So also relational databases are 100% SQL compliant, whereas Hadoop is more of a complex data, unstructured, very flexible and scalable storage, where we can go ahead and store all the information and process it in an efficient way. So apart from that, Hadoop can scale with different solutions, and it can integrate and work in a hybrid model. Comparatively, when you have to build a storage solution which is like more of standalone solution like RDBMS, Hadoop just differentiates itself, and it can integrate with either databases or with any other big data NoSQL solutions, and it can work in conjunction. So if you take Hadoop, so Hadoop can work with HBase, which is a NoSQL offering which is built on top of Hadoop. So it can scale to indefinite or hybrid models, so it's not restricted to the cluster scaling, so it can scale to robust solution needs as well. So that's very important. So in conventional RDBMS, that's not a possibility. You have to stick to that environment or the stack what has been provided by the enterprise data warehousing solution. So you have to stick to that, and you have to follow that one. Okay. The most important thing, so before we conclude, so what is that we would require to consider in what kind of situations? So that was our objective. So before we conclude, so consider data warehousing platforms built on top of RDBMS when you have to have low latency interactive reports, and you have to build a OLAP kind of an online analytic processing. Hadoop is not an online analytic processing. Hadoop is an offline analytics processing platform. So there is a huge difference, online versus offline. Hadoop cannot fill or fit the bill of online querying or interactive querying of your data. And Hadoop takes time to run the distributed processing and provide you the results. So that's where Hadoop is not the right choice if you're looking for a low latency, like I need the results or responses in 2 or 3 seconds, or maximum say 5 seconds. Yes, Hadoop can work in conjunction with some of the NoSQL or RDBMSs to deliver that solution. That's where we call it as hybrid solution. So if you need a pure low latency interactive reports OLAP kind of a thing, Hadoop is not the right solution. Data warehousing said that Hadoop can also work with the conventional data warehousing, interacting and providing you the massive scale. Okay, if you have a proper ANSI SQL compliance requirement, then the data warehousing kind of solutions fits the bill rather than the Hadoop kind of a thing. Hadoop also gives you the opportunity to interact with the MapReduce using the Hive abstract interfaces, but it is not the true ANSI SQL standards compliant. So it has its own way of interacting with the Hadoop. Okay, so when it comes to volumes of the data, huge volumes of raw unstructured data, so data warehouse cannot handle this kind of situation, so Hadoop is the best choice. And when it comes to archival or storing big data for all your historical data volumes, again your data warehouse does not fit into the bill. you have to go for Hadoop kind of a platform. When it comes to high quality cleansed data, so Hadoop is capable of storing raw data as well as cleansed data. You need a very high quality cleansed data on which you can immediately query, join the data, do all sorts of relational features. So data warehousing fits the bill. And moreover, both of them supports the concurrency aspects of Hadoop in conjunction with H-based kind of technologies. And also, say for example, if you have to do a parallel processing, so let's assume you have to do a massive parallel processing, RDBMS is not the right choice. That's where Hadoop fits into the bill. And some of the differences where I have shared is basically if you have unrestricted, unstructured data, ungoverned data, so again Hadoop fits the bill. And also if you wanted to go ahead and explore something which is massive, something which is very complex, which does not fit the bill of doing a simple joins or nested joins or 3 or 4 table joins. So there are very complex data structures which you have to analyze, which you have to do. Say for example, indexing the web cannot be done on indexing the web, and providing the orders or sorting cannot be done on a relational RDBMS. So you have to do it in kind of Hadoop kind of a platform. When it comes to recommendations on Amazon, YouTube, again those kind of things cannot be done on a straightforward RDBMS. It has to be done on Hadoop. So that's just to keep time check. So that's pretty much when you have to go for Hadoop and what you have to consider choosing the right solution. So being said that, I would keep the last couple of minutes for any Q&A. I'll see if I can take them, 1 or 2 of them, and see if I could.
Thanks for the insightful presentation, Madan. As you have just mentioned, let's quickly take up the questions now. I have to request you to read out the questions and their answers so that all our users may listen to your insights. So are you able to see some of the questions come into your questions doc?
Yeah, so I'll pick some of the interesting questions. So one of the questions from Utsav Verma is, if an organization is dealing with less than 1 terabyte of data, then would relational database be better? Absolutely, you're right, Utsav. So there is no point in storing or building big data clusters of Hadoop clusters just to store and work with 1 terabyte of information. So if your data size is just less than, say, 5 to 6 or 10 terabytes, it doesn't make any sense. So more than, like my personal recommendation is, if you have data volumes of more than 50 to 60 terabytes, go and look for a Hadoop kind of a solution. If it is like 1 or 2 terabytes, stick to RDBMS solutions that fits and that fulfills your needs pretty much. Okay, so I'll pick one more question, interesting question from Ankur. MongoDB versus Hadoop for big data. Why Hadoop can capable than MongoDB? Okay, great question. As I mentioned, MongoDB and Hadoop, they again solve 2 different purposes, just like Hadoop and RDBMS. You cannot compare MongoDB versus Hadoop. MongoDB is a OLTP NoSQL database which can support big data scale, and Hadoop is a offline analytics platform which can support big data. So there are 2 different technologies, so I would recommend not to compare these 2 technologies. Okay, so since I could see a lot of questions being streamed, so what I would do is we will persist all these questions, and you could use the Edureka staff, the Twitter handle, to post all your questions, the current questions as well as the future questions, and they'll get back to you on your queries and your concerns so that we could help you out in getting better understanding of it. So being said that, I would also briefly recommend you to check out the